Let us look at proposition number 20 of book 11 of Euclid's Elements. The proposition says, if a solid angle is contained by three plane angles, then the sum of any two is greater than the remaining. So let's see what this solid angle means first of all. So let's say we have three planes which are intersecting each other. And let's say this is the point of intersection of these three planes, A. Now, let's draw the lines of intersection. So if you notice that these three lines form three plane angles. And now to refer to them, let me mark some points. So here, AB, AD, and AC1 are the lines of intersection. So angle BAC is formed in this plane. So it is a plane angle. Angle BAD is an angle formed in this plane. So this is a plane angle. And angle DAC1 is formed in this plane. So this is a plane angle. But if we combine all these three, we get a solid angle. So we say a solid angle is formed by three or more plane angles. And here we are restricting ourselves to three plane angles. Okay, so that is what is meant by solid angle. Now we have these plane angles, right? Angle BAD, BAC1, and DAC1. These are the three angles. So what the proposition is saying is sum of any two of these three angles will be greater than the third angle. There is a case where all the three angles are equal. So if the three angles are equal to each other, that means there is, it is very clear that sum of any of these two will be the greater than the third. Now, so which means we have to think of the other case when these three angles are not equal. So let's look at that particular case. So now let's copy angle DAB onto AB at A in this plane. So we know how to do that. We saw it in book 1 itself. So we draw a circle with center at A and radius as AB. Next, we draw a circle with the center at A and AD as the radius. Then we draw a circle with B as the center and BD as the radius. And then we mark the intersection of the circles so that we get AE. So let's join AE. So now, because of the way we took the center and the radius, AD is equal to AE. Now let's join BE and extend it so that it intersects AC1. And let's mark that point as C. And now let's hide all the unnecessary elements. Now let's do a little bit of coloring work. So now we can proceed with proving that, let's take CAD plus DAB angle is greater than BAC. Let's look at these two triangles. These two triangles are going to be congruent. Why? Okay, let me hide off these angles. And remember, we copied these angles. So let's keep only those two angles. These two angles are equal because we copied this angle to the line AB at A. AD is equal to AE, again based on the construction. And AB is common. So they are congruent. Now, if these two triangles are congruent, it means DB is equal to BE. So now let's take the next step. Remember, these two triangles are congruent. Now let's focus on triangle CDB, the bottom triangle. We know the sum of any two sides of a triangle is greater than the third side. So that means BD plus DC is greater than BC, which can be written as BD plus DC is greater than BE plus EC. But BD is equal to BE, the way we constructed it. So that means since we said BD plus DC is greater than BE plus EC and BD is equal to BE, we can say CD is greater than CE, which means that angle CAD is greater than CAE. Why? Because again, one of the propositions we saw was that greater side subtends greater angle. In these two triangles, CD is greater than CE. So that means it is subtended by a greater angle. And greater angle is CAD. So we can say CAD is greater than CAE. Remember, these two angles are equal. So we can take this angle, angle DAB, and add it to CAD. And BAE, we can add it to CAE. So we end up with angle CAD plus DAB is greater than angle BAE plus EAC. So which means CAD plus DAB is greater than BAC. So we have proved that these two angles, when we sum it up, it is greater than the third angle. Similarly, we can show for the other cases that angle BAC plus CAD is greater than DAB. And CAD plus DAB is greater than BAC. And angle DAB plus BAC is greater than CAD. So all the possible options we can prove in a similar fashion. So that is proposition number 20 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.